So we've got the integral of x squared over the square root of 9 minus x squared dx, and because we've got this 9 minus x squared in the bottom, it's kind of looking like it's just a trig sub question. So what we'll do is we'll let x equal 3 sine theta, and I picked this because 3 is the square root of a squared here, because this has to be your a. And I picked sine because we're dealing with a subtraction here, and if we have subtraction, remember s subtraction means s, sine, or secant, and when a comes first, you always do sine first, because we learned sine before we learned secant, and it just makes sense that a is first, therefore sine is first. Anyway, to find dx, we simply just say 3 cosine theta, the derivative of 3 sine theta, and now we just pop it back into the original integral. So we've got x squared, which is 9 sine squared theta, over the square root of 9 minus 9 sine squared theta. And then we'll do our dx, which is 3 cosine theta d theta. This is our rewritten integral. Now we just need to purge the constants. So to do that, we'll pull the top 9 out, we'll pull the 3 out, and then we'll simplify this, right? So we've got the square root of 9 minus 9 sine squared theta. So pull 9 out, and then all of a sudden it's 1 minus sine squared theta down there. And we can separate these, square root of 9 times the square root of 1 minus sine squared theta. And this is just 3. So pull 3 out bottom, and they actually cancel with each other, times the integral now of sine squared theta cosine theta all over. And what we're left here with is 1 minus sine squared theta. That's what's really left up here. And that is just cosine squared theta. But because it's under this radical, under the square root symbol, that means it's just a cosine. So it's just cosine theta, all with respect to theta. So let's rewrite this cleanly now and go ahead and cancel these cosines out. Now we've just got 9 times the integral of sine squared theta d theta. And this is one of those instances where we've got a simple trig unit, but we have a squared there. So what we need to perform is a step-down trig property. And so that would be a 9 times the integral of 1 minus cosine 2 theta over 2. Had this been a cosine here, this would be a plus symbol. But because it's sine, that is minus d theta. So we'll pull this 2 out front. We'll have 9 over 2 times the integral of 1 minus cosine 2 theta d theta. And now we're ready to solve the actual integral itself. We'll say 9 halves times theta, because the integral of 1 with respect to theta is theta, minus the integral of cosine 2 theta is just sine 2 theta over 2, because we have to remember to do the chain rule on that middle function, plus c at the end there, because we're dealing with an indefinite integral. There's no bounds that we're adding here, and we have to add something, so we're going to add a constant. So now we've got everything still in terms of theta, and it looks to be solved, but it's not, because it's in terms of theta. We have to take things back to be in terms of x. So if we go all the way back up to the top here, and we see that we put x is equal to 3 sine theta, we'll rewrite that next to our triangle here, x equals 3 sine theta. That means that sine theta equals x over 3. And so what that means is, with respect to this theta here, our opposite over hypotenuse is x over 3. And so now we can solve for what's down here. And we're going to set this equal to just y for now, just for simplicity's sake. And we'll say hypotenuse squared, which is 9, equals x squared plus y squared. We're solving for y, so y equals 9 minus x squared, but square rooted. So this here is 9 minus x squared. And a decent indication on if you've done this calculation correctly is to always just kind of go back up to the top here and see if it matches your denominator. 9 minus x squared matches my 9 minus x squared. That's typically indicative of a correct thought process. There are some instances where it's not going to work, but for the most part, with most basic trig sub problems, that is the case. Anyway, so we've built our triangle. We're now ready to solve for the thetas here. We'll rewrite it as 9 over 2, And theta, because it's just on its own, we can actually just steal this here, the sine theta equals x over 3, and we'll just write this as sine inverse of x over 3. That represents our theta. Minus sine 2 theta, which usually when I see a sine 2 theta, I rewrite that as 2 sine theta cosine theta, especially when there's a 2 on the bottom there, because these 2's can just cancel. So we will rewrite it like that. We'll have 9 over 2 now sine inverse x over 3 minus sine theta is x over 3 times cosine theta, which is the square root of 9 minus x squared over 3 plus c. And then finally, 9 over 2 times sine inverse of x over 3 minus x square root 9 minus x squared over 9 plus c. That is the final answer. Most professors, though, will want you to kind of simplify this as 9 over 2 sine inverse x over 3, and then go ahead and cancel these two 9's, and just have minus x square root 9 minus x squared over 2 plus c. That is the true final form of that integral. If you have any other questions, or if you have any calculus or physics problems that you want me to work through, please let me know in the comments below. I hope you found this helpful.